Hello, I call this presentation Statistical My Dear Watson. So here you see Watson with Holmes. Watson was known for making suggestions to Holmes to help Holmes solve his criminal cases. So what I want to present here is a software that suggests to non-mathematical users ways to better use their data. So this is joint work I did with Monira Hamid at Al-Azhar University. She's a lecturer in the computer science department and a PhD candidate. We were supported by the Fulbright Scholars Program, U.S. State Department. So, I want to introduce My Dear Watson, which is open source software, free software, to empower non-mathematical decision makers to make informed data-driven decisions. Now, there are many data visualization softwares out there like Tableau and Microsoft Power BI that can create wonderful visualizations. Now, what we're trying to do is to target the non-specialist, the one who does not have a computer savvy and can only do simple manipulations. And we want to help them make the most of their data. And I'm going to introduce some features of My Dear Watson, and I'm going to do a case study of how it might be applied. So there's a great need for improved visualization of statistical data. Governments and NGOs conduct multiple myriads of surveys and generate lots of data, and usually the data are poorly represented and underutilized. One example is Nigeria's National AIDS and Reproductive Health Survey, a 527-page report with 200 tables and only 17 figures. This was a massive effort that took over a year, I believe, to assemble the data, and no politician or decision maker is going to make serious use of this information. It's too dense, and it's not presented in a very palatable way. Here's an example of a graph from that report. You don't see any pattern. You just see random bars here and there. You have some numbers. It's hard to make any sense out of this. Data should tell a story. So we're trying to help the user see the story in the data. So here's an example of some data generated by our system. You can see the scale is on the graph, so you can see exactly what the numbers are. In this case, we are actually looking at Sudan University admissions data to different departments. So here are the departments down here. And then this is telling whether the people got their top choice or not when they applied to these departments. See how the bars are ordered so you can see a trend? See the multiple ways of representing the same data? This is a parallelogram, and then here's a bar plot. So we try to help users make the most of their data. And these graphs will be generated automatically. So for at the top level, the user will receive these graphs, a bar chart, box plot, and parallelogram. And of course, they may need some instruction on how to read these. But I think it's easy to find visual details here to look at and to ask questions about. So our methodology is to have the user give their data, input, and we read in the data file. And then we use this data to generate a comprehensive set of graphs that give some information, particularly single variable histograms, two variable comparisons that do the three graphs that I mentioned already. Then we propose a list of exploratory questions the user may ask concerning the data, and then we enable the user to perform simple data modifications for further data or exploration. And the user may generate additional plots, and all graphs are stored, and the user may select and use at will. So here's a flow chart of how we envision the system might be used. Basically, just a summary of what I said on the previous slide. We'll take the original data, generate a comprehensive set of visualizations that the user can examine, select interesting graphs for further study, manipulate data to bring out essential features, and generate additional visualizations. So at this point, I think I will show the actual interface. So we are using RStudio, which is open source software. So it's available to anyone, anywhere in the world at no cost. So let me run the software. And I realize that this interface is not very friendly for people who are not computer savvy, but we're working on that. And these also menu options are kind of sparse right now, and certainly we'll improve those as well. So I do want to import my data, my information on the keyboard, so I say yes. My data is contained in a file called data1617, and notice that RStudio does suggest completion, which is a nice thing. And here I want to give a list of variables. So I'm interested in the sex of incoming students, and I'm interested in their home state, and I'm also interested in their GPA, which is a variable rank PCT. Okay, so those are my three variables that are already in my data file. I do want to generate a new data table, and then here's some other options I'm going to pass over for now. All right, so it's generated the data table, and let me show you what kind of plots we can make here. So I'm going to generate a plot. Now, if I don't know what plots can do, I put a question mark. This gives me my options. Now, what I want to do is I want to see how the GPA depends on the state that they come from in Sudan, and also how it depends on sex. So I can plot the var variable will be home state, the state the student comes from, and then I want rank PCT, and then I want sex, so I'll get a representation by sex, and I want it to show in this window, so I'll put an @ here, and hopefully I did everything right, and we can see the graph over here. So here's the graph here. You can make it larger. I can save it to a file. I can change the bar order. I can change various things about the presentation. And you can see that the bars have been automatically ordered in a reasonable way. You can see patterns. This was done using a mathematical algorithm called the traveling salesman algorithm. So that can help the user understand what their data is saying. Now, if I wanted to do a nominal plot where I have this is a percentage plot. If I wanted to do a nominal plot, I can go back and do another plot here. And I can do, let's do the same thing, home state, rank PCT, sex, and then I want this, and then I want nominal plot. So you can see that there is a certain amount of variety in the plots that I can generate. Okay, so there is quite a bit of liberty to do stuff with your data. Right. So we do also suggest to the user various questions they can think about in analyzing their data. All right, so here let me do a case study of usage. Malaria data. This is the Nigeria health survey that I talked about before. And the question that we want to investigate is, how does BedNet usage depend on education and income? BedNets are a proven anti-malarial prophylaxis. BedNets are distributed in Nigeria. And we want to see how levels of usage and how that depends on the people's education and their income. So we have three variables of interest: education, BedNet use, and income level. This is a huge publicly available database that we used here. And so the system will automatically generate some graphs. So let me show some of the graphs that it generates. Whoops, sorry, let me go back to the next slide here. So here we have actual BedNet usage. These are the four categories. 1 denotes partial usage, the 2 denotes full usage, and 0 denotes they don't have a BedNet, and 3 denotes that they have a net but they're not using it. So you can see that the red and the purple denote BedNet usage, and the green and the blue denote no usage. So you can see the relative sizes. So most people have partial BedNet usage. And let's see how that depends on education level. Now remember that red and purple are BedNet use. So you can see from this graph here that there is more BedNet use for people who have lower education level. That seems rather strange. You would think that higher educated people would understand the importance of BedNets, but that's not what's happening. It's the lower educated people who are using BedNets more. The parallelogram also shows that, say, for instance, secondary and higher, these two categories are very similar statistically and maybe could possibly be combined into one category. All right, let's look at BedNet usage by wealth, and we see something similar. 5 is higher wealth, 1 is lower wealth. The higher wealth people have less BedNet usage, less red, less purple. Here again, we can see that these two categories are very similar and can be combined. So that's a way that the user can simplify their data. So now, of course, wealth is going to be correlated to education. The more education, then the more wealth you're going to have. So which of those variables is more important? Let's take a look. If we look here, we can see that for each education strata, still the poorest use BedNet more. However, if I look across the different wealth strata, the education does not make much difference. So we see that it's wealth and not education that's driving BedNet use. And when I presented this in Nigeria, they recognized exactly why that is, because people look down on people who use BedNets. It's thought of as not high status, and people who are wealthy prefer to use air conditioning or some other methods like that. They close their houses up. Okay, so for future work, there's a lot of things we can do. We can improve interface and other things like that. My time is up, so thank you for listening.